I'm happy to tell you a little bit more about the Micronaut framework and how to deploy some microservices, some functions, apps, containers, etc. on Google Cloud, and in particular the serverless products of Google Cloud. So I'll start with a few useful links. So if you want to have a look at the slides, if you want to see also, there's a GitHub project with all the samples, all the little demos I'll be showing you. And I wrote several articles on that topic on my blog. So feel free to have a look at these links and resources if you want to learn more and dive deeper in this topic. So my first chapter is going to be an introduction to Micronaut. So Micronaut, it's a microservices and serverless focused framework, but not only, it does way more than this. So first of all, it's an open source project as well. You can write all sorts of apps. I'll be showing different kind of examples in the next slides of the kind of apps you can create. One key thing compared to more, let's say, classical frameworks, it's using an annotation processor. So it's the usual annotation-driven programming approach when you use Micronaut. But there's an interesting aspect, which is its annotation processor, which actually hooks into the compiler to wire everything at compile time. Sorry, not at runtime. And that's a key aspect which makes Micronaut applications start super fast and use also less memory, but we'll come back to that. And also, Micronaut is made by folks that worked on the Grails web framework and know the Spring framework very well. That's my friend Graham Rocher, who created both Grails actually and the Micronaut framework. So with Micronaut, what can you build? I'll focus on the first couple of bullet points in this presentation. But so yes, you can create microservices, serverless applications. You can also create message-driven applications with Kafka, RabbitMQ, etc. You can actually also write command line tools. So it's not just for web apps and things like that. You can actually create command line tools as well. You can even create mobile applications. You can create, well, basically anything with a main method. You can do that as well with Micronaut, with dependency injection, etc. And since I'm the founder of the Groovy programming language, I have to mention that you can also write your applications using the Groovy programming language, but of course, Java and Kotlin as well. Yeah, I went too fast. So a few key features. So it's as I said, it's the familiar annotation-driven programming model. So you have to annotate your controller with @controller. You can use the Jakarta inject annotation, etc. So you annotate things here and there, methods. If you create an HTTP endpoint, you can say, okay, @get. @consumes that kind of content type and so on. So that's annotation driven. Under the hood, it's using Netty for the non-blocking HTTP server. You've got the ability, I don't think I'm using that in the demos, but a cool feature that I like is the ability to create declarative reactive compile time HTTP clients. That's a bit of a mouthful, but you can create an interface and annotate it with @client, and it's going to create, but at compile time, not at runtime with a proxy or anything of that kind. It's going to create a class implementing that interface that interacts with that particular service, URL, etc. And the marshalling is done totally transparently. That's a pretty brilliant feature. What else? There's an easy data access layer. So it's Micronaut data. I'm not going to show it today. And the fact that it starts super fast, when you want to write tests, you don't have to emulate the framework itself. You just run an instance of your application and you test that running instance rather than doing something more complicated for testing your applications, because it starts in really no time. Some of the features, there's an open API support. So if you want to expose your APIs via open API, etc. Well, there's lots of stuff beyond this small list of features. One thing I'd like to mention as well is to get started, something I would encourage you to use is the Micronaut Launch page. Actually, I can show you that page here. I think I've opened it somewhere. Yeah, Micronaut Launch. So you just go to micronaut.io. Whoops, what did I do? Launch. Where's it gone? Yeah, here. Micronaut.io/launch, and you'll be able to configure your. It's going to create a template for your project with some settings. So, for example, you can choose the version of Micronaut application you want to build. You can say, actually, it's a command line app, etc. So it's going to scaffold everything. You can pick up the version of Java you want, the name, the base package. Then you can pick up the language, Java, Groovy, Kotlin. You can build with Gradle or even the Kotlin DSL for Gradle, with Maven as well. For testing, you can use JUnit if it's pure Java, maybe. Spock, it's built with Groovy, but you can use it for any language that you may use in your app. Or Cotest, which is more a better fit when you develop Kotlin application. And a few things, you'll be able to click preview to see what it's going to generate. So this one is just pretty much an empty one, but you can add features, and there are tons of plugins and integrations. So for example, let's say I want to add GraphQL support. I want to add, I don't know, some GitHub what else? Some caching, etc. It's going. You can do that, or Kubernetes integration, etc. And you'll be able to see also the changes compared to the default template. Okay, so if I use GraphQL, it's going to add this dependency, etc. So, and oh yeah, last thing I'd like to mention, it's this generate button. So you can either download a zip file of that application. You can see the commands that you have to run on the command line if you want to generate that from your shell, your terminal. Or there's even an integration with GitHub, so you can push directly to a GitHub project. So that's pretty cool. Okay, let's move back here to the slides. There's support in IDEs. So for example, here, that's a screenshot of Visual Studio Code. So there's a plugin, which is actually part of the Graal VM tooling stuff. Because Micronaut, I didn't mention it yet. We'll see that in a minute. There's a Graal VM integration as well. To start even faster in a few milliseconds. I don't think I have I don't have a screenshot of this, but there's a great support for Micronaut in IntelliJ IDEA as well. So that's what I'm going to use actually later on in my presentation. And so to step back a little bit on why Micronaut came to life, if you look back at classical frameworks, the problems we often see with those the nice programming models that they offer, often annotation driven, etc. To simplify the life of developers, what they do is actually they generate lots of stuff at runtime. So there's lots of reflection which is used. There may be some runtime bytecode generation that is used again at runtime. When I say reflection as well, it's memory consumption that comes from that, because there's lots of caching of what methods a class has, etc. So it builds up a build cache. You may have some generated proxies to do AOP kind of stuff transparently for you, and also dynamic class loading. So those things are often time-consuming at runtime. at startup time and consume quite a bit of memory. And this is related to Java's own problems. So, for example, there are some issues, for example, like when you annotate, or not when you annotate, but let's say you have some collections which use some generics. At runtime, because of type erasure, you don't know what collection, what list, a list of what kind of object it was. Reflection usually isn't very fast, so that's often why frameworks reinvent their own bytecode stuff for reflection. I mentioned the reflective data caches, which are a big. Even if you don't need everything, you may just need one method and not the whole information about the structure of the class, methods, etc. Another thing that simplifies the developer experience, let's say, it's the class path scanning to find all the components that make the application, but it can be slow, and in some environments even slower, and slow dynamic class loading. So if you add all those problems, usually it makes startup time slow and consumes memory. But fortunately, so Graal, before speaking about Graal, Micronaut does it differently because everything, thanks to annotation processes, is done at compile time. So when you start, so it may spend a little bit more compilation time, but not that much, not very noticeable, honestly. But then when the application startups, it indeed uses less memory and starts super fast. And the fact that it's done at compilation time also helps with the GraalVM support, because there's GraalVM support, so you can build native image out of your Micronaut applications. So with that, it increases the app throughput generally by a fair percentage, reduces latency, replies more rapidly to requests. There's a faster startup time as well, potentially down to 20 milliseconds. Also, little memory consumption as low as 18 megabytes. And also the fact that you can create native images, you can create one small binary file, and it's easy to just either containerize that or deploy somewhere. So that this integration, GraalVM improves a lot over the past few versions, over this past year, etc., to make things easier to create native images. But in the past, it was a bit more complicated. But and especially with, let's say, frameworks that use a lot of reflection, etc., it was more complicated to create native images with GraalVM. But the fact that Micronaut does lots of work at compilation time, again, it's really great because it also helps GraalVM. It simplifies the job of GraalVM for creating native images. All right, a quick intro to where I'm going to deploy my Micronaut demos today. I'm going to speak about, because I work for Google Cloud, I'm going to speak about Google Cloud Platform for deploying your applications. So, as you probably know, Google Cloud offers one of the biggest global set of data centers in many regions and zones, etc. There's a huge family of products in all sorts of categories. Today we'll focus more on the compute aspect, but there are databases, there are all sort of cool things. And if you look at the compute spectrum, when you use serverless, the more to the right you go here, the more you're going to focus on your code. So if I focus on a serverless container, for example, using Google Cloudrun, I can focus on my apps, the runtime I chose, the underlying operating system, at least the base image that you use in your containers. With App Engine, it's more like a platform as a service. So you deploy an application directly to the platform. And with functions as a service, with Google Cloud Functions, you just deploy one function, one method, or, well, small application. Some advantages of serverless solutions, so you don't have to focus on the infrastructure management. Security is managed for you as well. It's a pay-as-you-go model, so it doesn't cost you anything if the code is not running, but it can scale to infinity and beyond, or in a way, the more traffic that you get. Okay, just a simple definition of what serverless is. So as I said, there are three key offerings there. Cloud functions, usually for source-based kind of deployments, for event-driven functions, but it can also answer HTTP requests as well. App Engine, as I said, it's more like the venerable platform as a service concept. So you can either do source or compiled deployments of web apps, web front ends, or web API backends, etc. That's a good fit. And then you have Cloudrun, what's interesting here is that with Cloudrun, you're going to containerize your application, but it still exhibits the same serverless characteristics. So scale to 0, scale to infinity, etc. So let's zoom a little bit on Cloud Functions. With Cloud Functions, what I like to compare that to a kind of glue where you can glue different services, APIs, events together. With Cloud Functions, there are two kinds of functions, actually. Background events functions, so you can, for example, react to incoming Pubsub messages or a new file stored in a cloud storage bucket, for example. You can also, without having to buy and pay for an API gateway or anything of that kind, you can reply directly to HTTP events as well. So there's no complicated setup. It's out of the box. And with functions, so usually it's not so much for synchronous kind of use case. So it's more for event-driven asynchronous kind of scenarios. So it may be for webhooks, IoT backends that send sensor data, some lightweight data munging, chatbots, etc. There are 7 key languages that are supported, runtimes that are supported: Node.js, Python, Go, Java, .NET, and Ruby. There are also some open source ones that you can run on top of Cloudrun for Dart and C++, I think. But the ones that are fully managed on Cloud Functions are those 7 ones. And so you can react to all sorts of incoming events and call in return all sorts of services, machine learning services maybe, hosted on Google Cloud, or let's say you want to send a text message with Twilio, you can call third-party services, etc. So when is it a good fit to use Cloud Functions? It's fairly easy to deploy bits of code, small functions, etc. It's great for asynchronous event-driven scenarios, Pubsub images, etc. It's nice for webhooks, as I said. Constraints, you may be constrained by the set of runtime languages that are available. So if you want to do, let's say, Rust or Fortran, well, there's no runtime. But if you're happy with one of the 7 ones that are there, that's just fine. And today we'll use Java, obviously. Yeah, what else? No custom domain. You can set that up, but it's a bit of work. The default concurrency, when you hit a function, there's only one event that can hit a function at a time. So we spin up as many functions as needed. But there's a second flavor. So the new version of Cloud Functions allows a bigger set or level of concurrency, for example. So and I wouldn't use Cloud Functions for like web front ends because of potential cold starts, etc. So that's more for asynchronous kind of work. With App Engine, again, same thing. There are 7 runtimes that are available. For Java, we have Java 11 and Java 17. So we focus on the LTS versions rather than each and every version. So there's no Java 20, for example. And I think the next one, the next LTS will be 21, if I'm not mistaken. So in 6 months or before the end of the year, you should have Java 20 if you want to use that. A couple of things that I really like, traffic splitting. So if you want to have different versions of your application, and split traffic, do A/B testing, blue-green deployments, etc. You can do that. Concurrency, so there's a high level of concurrency. You can have custom domains, and a key thing that I like, it's the built-in CDN for static asset serving. So you're not feeling the cold stuff that you can have often on serverless, because if you have a web application, all the HTML, CSS, JavaScript will be served immediately by the built-in CDN. And I mean, the app has time to load, even if it's a cold start under the hood. So it's totally transparent for the users. So it's great for stateless apps, for all kinds of HTTP request response-driven workloads. The built-in CDN is really cool. And there are some limitations, again, if you want to use an esoteric language, or there's no support for things like streaming, HTTP2 streaming, gRPC, WebSocket, server-side events. But if you use Cloudrun, you can do that. So a few words about Cloudrun. It's based on containers. You can put any language library binary in your containers. Obviously, there's a rich ecosystem of base image you can build upon. But you've got the velocity of serverless. When you deploy stuff, it's trivial. You don't have to prepare, monitor, provision clusters or anything of that kind. You just deploy to a managed service, and you also have the flexibility of container, developer experience, and the fact that you can put anything inside your containers. Well, I'll skip that. It's also based on the Knative Kubernetes API. So there's a high level of portability, because you could run a Cloudrun container elsewhere, even on your own Kubernetes cluster. What's interesting there? Containers can run up to 60 minutes. You can have between 128 megabytes of RAM up to 8 gigs. And also for small functions, for example, small apps like Micronaut apps, you can use smaller containers. Yeah, that's pretty much it. So it's great for serverless workloads, HTTP request response driven workloads. It does streaming, so that's cool. It scales quickly and down to 0 as well. But you don't have like the same built-in stuff that you have on a platform as a service like App Engine. Okay, so it's time for some demos. Okay, so I'll start. So first of all the code is available, as I said, on this GitHub account, Laforge mn-gcp. Again, you can see some articles on that topic on my blog, glaforge.dev, Micronaut Launch. I can close that. So let's start with a few functions. So I have deployed 2 functions, an HTTP function and a Pubsub function. So that's the 2 families of functions. So let's start, let's say, with the Pubsub function. The Pubsub function, so there's a Pubsub topic. Actually, let me click on trigger and click here, and I'm going to send a message to my function. I'm going to show you the code in a little bit. So I think it's messages and publish a message. For example, I want to say, can put a text message, for example. So I don't have Cyric typing there on my keyboard. So let's say I want to send, I hope there's no typo, at least with this notation, and I'm going to publish a message on a topic. And I'm going to look at the logs and see if, okay, I'm going to reload. There's always a big latency with the logs, like 10 seconds before I actually see the messages. And okay, yeah. So this is my message. It was the Pubsub message was received by the Cloud function built with Micronaut. And then let me show you. I hope this works. If I don't know why it's not switching to. Oh, it's gonna be painful. If I have to change the because I want to show you my ID now, or Well, let's do it different. I'm going to stick on this window, but I'll show you the code from GitHub rather than in the IDE. At least I can switch between tabs. I don't know why I can show you my IntelliJ IDE. I don't know. So yeah, my functions. So this is the first function here. So the function, or maybe let me try one more thing, because I can share the entire screen rather than, because my mistake, I think I shared a window. Okay, so let me try that again. Okay, so let's see if it shows up. And now it works. Woohoo! So yeah, I want to go into my IDE. Functions, as I said, Pubsub, it's here, and I'm going to open my Pubsub function. So here is my Pubsub function. You have to implement, so there's an open source framework called the Functions Framework, API or framework, that has two different kind of interfaces that you can implement. Here it's a background function, and I'm going to use my own payload, which is a Pubsub message. So it's going to be marshaled and marshaled automatically. And for the Micronaut integration, there's a special class that initializes the Micronaut application. So I have to do those two things, and then the simple thing that my function is doing is that it's going, so I inject my own service there, and I'm going to call that service. So it's a singleton, again, the Jakarta annotations. So it's injected automatically in this Micronaut class. And then I'm actually unbundling the data in the Pubsub message. And then I just log with a proper logger this time the message. So that's why you were seeing in the logs of my function Slava Ukraini. Okay, so that's a first. So it's fairly easy to implement a function that reacts to Pubsub messages or all sorts of backend events. Now I'd like to show you a webhook service. So it's an HTTP function this time. And for an HTTP function, it's actually just a plain Micronaut controller. So it's a class annotated with @controller. And yeah, I'm going to produce some plain text. It's going to reply to get here. And there's also another endpoint that, well, it's the same endpoint, but that receives post request. So if I go back here, so what I did actually is that I configured this project with webhooks, and I point at my function URL. And if I, let's say I'm going to commit something to like the README file, okay, very quickly, I'm going to, let's say, add a dot here, commit change, builders change. I commit directly there. So I've got this change committed, and then I'm going to look at my other function, which is hosted there. And you're going to see in the logs in a few seconds, 10 seconds or so. No, that was yesterday. So let's reload that when I rehearsed. And there should be, my function should be called. Yeah, that's this morning. And indeed, I received the GitHub payload related to the commit that I did on my project. So again, fairly simple to create controllers and reply to all sorts of events. Now I'll show you App Engine. So I deployed, so I think that's this one. I deployed a simple application. So it's HTML, JavaScript, etc. But the fruits here are populated by the backend API part of my App Engine application using the Micronaut framework. What was interesting is that maybe you didn't notice, but because of the CDN asset serving, it loaded immediately. There was no cold start basically. And then I was able to populate that transparently, and the user wouldn't see the number of calories in a banana. Okay, so if you look, so I've got two services that are deployed there. So let's move to App Engine. App Engine. So there's my backend. So you're gonna. Oh yeah, I can show you that. I've got a special App Engine configuration file that says, okay, here are all the static assets that should be served by a CDN. And then I have my fruit controller, which is going to, so again, it's a controller, it produces some JSON content, and it marshals and marshals automatically a list of fruits. And I've got my fruit class here. I could probably use records. That would be just like Adam said earlier. I should update my code with records as well. And all the static assets are there and served by the CDN. Is there anything else I wanted to show there? No, I think that's all. And then I just deploy that. So I don't show you the deployment because it takes a couple of minutes. But there's a gcloud SDK that you can use on the command line to deploy, or you can use the web UI as well if you want to deploy. Interestingly, I also did a similar. So that's the other one that I deployed. So although I'm using a Java runtime, here that's the Java 11 runtime, there's a way to actually configure the entry point of how you start your applications. Under the hood, it starts with Java-jar or something, or to start your Java application, your Micronaut application. But you can also customize. So I'm going to show you this other one. You can also customize. Where is it? I think it's in the stage folder. You can also customize the way you start. So again, that's the application YAML configuration file for App Engine. I can define an entry point, and the entry point, instead of being the default Java entry point to start Java application, I can even start binary. So I'm using the Java runtime, but I've created another service. I forget what's its URL. It should be, so I can close this one. And it's, I think, vegetable. Yeah. So that's similar to the other one, but this time with vegetable. So that's the endpoint populating the front end. And this one is actually my Micronaut application, but built with GraalVM this time. So I built a binary and I deployed that binary that you see here. The application is just a binary created from my application. But I'll show you that maybe in the context of Cloudrun. So for Cloudrun, I'd like to show you two demos. So I've deployed that backend application, that backend vegetable thing here. Vegetable backend. Oh, I should probably, well, in the interest of time, I won't show you that, but or maybe we can see that at least in the. Well, you won't see the difference, but the application starts faster. Of course, like, so for example, with the current CPU, memory, etc., that I've set up for Cloudrun, Micronaut app would start in about 1 second, but when I compile it as a native image, it builds, it compiles, it starts up, sorry, not compiles, it starts up in like 250 milliseconds. But it can be even faster with a bigger CPU, because I used a small instance for my app. And there's one last demo I'd like to show you. So as I said, with Cloud Functions or App Engine, you cannot do streaming. So WebSocket, server send events, HTTP to streaming, gRPC streaming, you can't do that on Cloud Functions or App Engine. But with Cloudrun, you can. There's support for all of this. So I've created another application that actually uses server sent events. So I need to remember the address. Oops. So this is the root of my application, but the path, I think it's live feed. Yes. So here I'm going to send events. every 500 milliseconds, I actually roll a dice, right? So there's a value between 1 and 6. And this, I don't know if I can, no, that's the source. I wanted to show you maybe if you look at the network, you might see, actually, can you see it with the, well, I didn't try it, but well, I wanted to say that it's really server sent event protocol that's used there. So it keeps on delivering new values. So let's see. So this is streaming server sent events. So let me show you this last thing. So I'm going to close that and show you my live feed. Here, live feed controller, and double click. Ah, where's it going? It's here. So this time, again, a new class, new controller, and I'm going to use reactive programming basically with publisher and also events for producing. So this is here that you see that it's the event stream, servers and events content type. And it's using task executors IO to not clog the main event loop of the framework. So what I'm doing here, I've got two flowables, one which generates ticks every 500 milliseconds, and I've got another one, each time it's going to generate a new dice roll. So I'm going to create a new, well, it's shown actually here. When you combine the two flowable, the two streams together, there's going to be a time and a dice roll for each increment of time. And it's going to create an event object that maps, that wraps an ID, the ID of the event, and the dice roll actually with a value. So that's why you see here the ID that's generated and the marshaled data, which represents my event. And then, yeah, and I think that's pretty much it that I should explain about that example. So with that, I think that's about it. I have like 5 minutes or so for some questions. So it went pretty fast. Would be nice to have even more time to dive a little deeper and show you like how fast it starts or things like that, or deployments, etc.
Thank you, Guillaume, for this demo and highlighting Micronaut. Yeah, it was tough due to time constraints. Thank you for being flexible. And we have a couple of questions to you. So
Cool.
first of all, how do you approach testing on your Micronaut applications? Does Micronaut provides convenient tools for system testing?
For system testing?
For system testing.
Yeah, so there's a really great level of support for testing Micronaut applications. So, well, at least for unit testing, etc. As you saw, you can use different frameworks. The thing that I like and that I mentioned is that your applications are actually running as the real applications. So it's not an emulated environment that when you run your application within a test. So I'm not showing that in these demos, but you really start the same application that's going to be deployed on the cloud, on your server, etc. So you have a certain level of faith in what your tests test when you run them as unit tests within your IDE. And then there's yeah, all the testing facilities that are available, the HTTP client support, the declarative HTTP client, you can use that to also test when it's deployed on the cloud or elsewhere, and point at where your service was deployed and use it as if it was local in your test cases as well. So yeah, it's worth looking more into the documentation to learn more about the testing capabilities.
And what's your opinion about differences between service-oriented architecture and microservice architecture. Which one is more suitable for Micronaut?
Actually, I don't think there's one that's more suitable for Micronaut than another one, because I think it's a great fit for the different approaches. I like the fact, I mean, for even driven architectures, often it's more asynchronous, so you usually care less about startup time, etc. But for example, when you've got stuff that's more synchronous, it's more interesting to have something that starts super fast and consumes not much memory. And Micronaut offers that. And so, for example, I'm also covering this area of service orchestration, etc. I'm presenting talks as well on this topic. This is more general, not specific to Micronaut, but I mean, when you use orchestration, when you have business processes that can be more easily represented as a flow chart, you can describe, hey, I'm going to call this after that, fetch that data here from that Micronaut service, etc. It works just as well, just to point at Micronaut services compared to a purely event-driven approach. So, I mean, Micronaut is great in the different scenarios. I wouldn't say that it's better at one particular scenario than another.
I see. And though we didn't reach the deployment section, what do you think? Which technique would you recommend in microservice world? Maybe in which scenarios, like blue, green, rolling? Which do you prefer to use?
So, well, I'm perhaps because I'm I'm using Google Cloud because I work there. But I like the fact that all the services that I use offer traffic splitting. So you can actually implement the different traffic splitting strategies for functions, for apps, and for Cloudrun. So regardless of whether you use Micronaut or not. So I actually like deploying, let's say, do traffic splitting and deploy 10% of direct 10% of the traffic to a new version. So via traffic splitting, I tend to use that, or more blue-green deployment rather than canary. But I guess it depends on your practices internally, because you may want to do canary because you're used to. I mean, your internal processes have some kind of Q&A aspect, and maybe you have a Q&A team that takes care of things like that. So I think, again, it depends more on best practices in your company and your team rather than the technology, or even whether you're using Google Cloud or something else. But at least with Google Cloud and with Micronaut, any of those approaches are fine as well.
William, I'm afraid we're running out of time. So Thank you for your time. Thank you for your presentation. We have to do a little break for next speaker to be prepared. And special thank you for Groovy from all Gradle people. See you and have a good day.